in our video that we'll look at in class today is the objective that we will use the projectile motion equation to find heights of objects. So for you, once you finish watching the video and work a few problems, you will be able to apply the equation to find heights of objects. And what we're talking about are, say maybe a ball is being bounced, or in this case we're going to look at a golf ball being hit, and like a football being kicked. Okay, so let's take a look. So any object that is thrown or launched into the air, so I said we can include the baseball and basketball and soccer ball, we refer to those as projectile. So we have a general function that we use that approximates the height in feet of a projectile on Earth after t seconds is given. And here it is. So we have our constant, which is the -16, due to the Earth's gravity in feet per second. We have our initial velocity, and that is in feet per second, and our initial height. I want you to pause the video, and I want you guys to copy this down before we continue. And I also want you to realize that the model will have its limitations because it doesn't account for things like air resistance and wind, and of course any other real-world factors that we have. So let's take a look at one. All right, we have a golf ball is hit from ground level with an initial velocity of 80 feet per second. After how many seconds will the ball hit the ground? So we're going to write down our function. So our -16t squared plus our initial velocity, or vertical velocity I should say, plus our h naught. So all we're really going to do is we're going to replace in that vertical velocity. So do that. And we now have -16t squared plus 80t plus 0. And what we're going to do is we're just going to continue what we've been doing, and that is we're going to factor and we're going to find our zeros. So if we want to do that, we want to set our equation equal to 0. So if we do that, we would end up with -16t squared plus our 80t, and we're going to set that equal to 0. We've lost our initial height is the ground, right? So he's going to start on the ground and then be projected up into the air. So what do we always look for? We're going to factor. I see that we have a t in both. I'm going to change colors here. You see that we have the t that we can take out. Also, we can take out a 16. You notice that the 16 is negative, so we're going to take that out with it. So if we factor out a -16t, that's going to leave us with a t in our first term. Now remember, we're taking the negative out, so when we do that, that changes the sign, and that plus would become minus, and then 80 divided by 16 would be 5. So now all you have to do is find your zeros. Either the -16t is our 0, or the t minus 5 is our 0. So we get over here, t would be 0, and over here we would get t to equal 5. So we know that the golf ball will hit the ground after what? After 5 seconds. Okay? All right. So if we take a look at the graph of our golf ball, we see that, in fact, we have its zeros at 0 and at 5. If we were to put this into our y equals. So here's at 0. So this is where we started. He started on the ground. He was projected into the air. Whatever goes up must come down, right? So here's your parabola. And you see that he crosses at 5. Okay, pause if you need to, if the class needs to, and then let's continue on to another one. Okay, here we have a football. And it's going to be kicked from ground level. So here you go. Again, we have the initial height at 0 with an initial vertical velocity of 48 feet per squared. How long is the ball going to be in the air? Okay, so we're going to set it up again. We're going to write that general function. And again, we're going to just replace into our initial velocity. And we're going to put that in at 48. Okay. We want to find the zeros because we want to figure out how long it'll be in that air. So we're going to start again at 0 and find, or set this equal to 0 to find our second 0 because that's when it will go back to the ground. So setting this equal to 0, right? We would have negative 16t squared plus 48t. Again, we've got that t that we can take out. Let's change colors. Again, we've got that t we can take out, and we can also take out the 16. Again, we're going to take the negative out with it. So if we do that again, negative 16t, we'll be left with a t, and then again, remember this sign changes, t minus, and 48 divided by 16, I think is 3. So let's set that. And we know that that is equal to our 0. So let's just solve it. Either the negative 16t equals 0, so we know that that would be 0, or the t minus 3 equals 0, and that would be 3. So how long was it in the air? How long was the football in the air? Okay, did you tell 3 seconds? Okay, let's take a look at that. So let's scoot it down here. So here we are. We're at the ground. When it started, it was at 0 right here. So he kicked it up. It went up. It hit that maximum point, and it came back down. And you see that it was at 3. So it was in the air for 3 seconds. Okay. All right, so I've got 3 problems that I want you to work right there in class. You can work with your partner if you would like. I'm going to have Mr. Ulrich give you about 10 to 15 minutes to complete this. And then once you are finished with it, I will have Mr. Ulrich look over those, and I want y'all to pass those in to him. And once you're done with this, you're going to, he's going to pass you out another worksheet, and you're going to work on your completing the square activity. Remember, I have also posted that in the lectures if you want to go back and review it. And I will see you guys in class next time.